Hello everyone and welcome back to the GT Improvement channel. Today we are going to be working on part 31 and we're going to be doing some word problems involving the formula rate times time equals distance. But before we get started, please don't forget to hit the subscribe button below, and if this channel is helping you, please share this completely free resource with other service members who might also be looking to improve their GT. All right, let's get started. So rate times time equals distance. Definitely a formula you need to know. So this formula, if you see in a word problem someone or something traveling at some rate for some specific period of time and goes some particular distance, this is the formula that you're going to need. So real quick, let's just talk about what rate means. The most common rate that we know is miles per hour. We see mph. But really, rate can be any unit of measurement per some unit of time. So miles per hour, feet per second, inches per minute, miles per day. These are all examples of rate. Some unit of measurement per some unit of time. So let's just do some sample problems. So if your rate is 30 miles per hour and you drive for 3 hours, how far will you go? So if you see something about rate, time, and distance, I would just really quick write out your formula. Rate times time equals distance. So in this case, our rate is 30. And it says we drive for 3 hours, so our time is 3, and it's asking us for our distance. So all we need to do is multiply 30 times 3, which would be 90, and that would be miles. Okay, pretty easy. Just write out your formula, plug in the numbers wherever they're supposed to go, and then do your math and solve. All right, let's do another example. You drive 300 miles in 6 hours. What is your rate? So in this case, we are looking for the rate. We don't know that, that's our variable, but we know our time is 6 hours, and we know our distance is, 6 hours, and we know our distance is 300 miles. So now to solve for R, this is gonna become algebra. We're gonna divide both sides by 6, and 300 divided by 6 is going to give you 50. So our rate is 50 miles per hour. Okay, last one, and then we'll do some word problems that are a little tougher. So you travel at 25 miles per hour. How long will it take you to go 150 miles? All right, so we have a rate. That is 25. The question is, how long will it take to go? So that is the time. We don't know that, but we do know that our distance is 150 miles. So to solve for t, in this case, we're going to divide both sides by 25, and 50 divided by 25 is 6 hours. Okay, so pretty easy. Just make sure you're plugging the right numbers into the right places and you'll be good to go. All right, let's do some tougher word problems. So go ahead and start number 1, 2, and 3 and pause your video, and then we'll go through the answers. All right, so for number 1, a tugboat travels at 4 miles per hour. How many hours will it need to go 18 miles? So formula again is rate times time equals distance. In this case, we have the rate, that is 4 miles per hour. We do not know the time, that's what we are looking for, and our distance is 18 miles. So to solve for t, we're going to divide both sides by 4. And if you notice in your answer choices, you've got answers that are pretty far apart here, except for maybe these two. But since these two are in the form of a mixed number, I'm going to go ahead and solve this like a mixed number. So I have an improper fraction here. I'm just going to change that into a mixed number. 4 can go into 18 4 times with 2 left over. Denominator stays the same, and that simplifies to 4 1/2. Now you could have just stopped at 4 because there's only one answer choice that has 4 in it. Okay, for number 2. All right, it says a man jogs at the rate of 5.3 miles per hour. How far will he jog in 3 1/4 hours to the nearest 1/10 of a mile? So in this case, since my answers are all in decimals here, I'm going to change this 3 1/4 fraction to a decimal. So our rate is 5.3. Our time is 3 1/4 hours, which is 3.25, and we are looking for the distance. So when you multiply these two numbers together, you should end up with alpha. It actually works out to 17.225, I believe, but we only need to the nearest 1/10, so that would be your answer, 17.2. Okay, for number 3, a car averages 55 miles per hour on a trip of 1,265 miles. How many hours did it take to make the trip? In this case, our rate is 55. We are looking for the t, and our distance is 1,265. So we just need to do this division. And when you do that, you should end up with alpha, 23. Okay. Number 4, 5, and how about number 4 and 5? Because that's all I can show on my paper. All right, number 4. A man drove his car 2,400 miles in 3 days. What was his average rate of speed? Tricky problem. So a lot of people tend to mess this one up. So if you notice your answers here, you have 3 answers with miles per hour and 1 answer with miles per day. Now, a lot of people, they want to rule this one out completely because they're like, I never see miles per day. I've only seen miles per hour. That's true. Usually you don't see miles per day, but this is still a rate, so you still need to consider it as an answer choice. So if you do your rate times time equals distance, the rate is what we're looking for. It says the time is 3 days, and the distance is 2,400 miles. So all you have to do is divide by 3, and 2,400 divided by 3 is 800. What a lot of people want to do, and I think I did this the first time I did this problem, is they want to change the number of days to hours. So they end up doing r times 72 equals 2,400. And when you divide both sides by 72, you end up getting 33 1/3, or 33.33333, repeating. And then what a lot of people say is, oh, that's pretty close to this one, so I'm just going to choose this one. But that's not the exact answer. 33 1/3, that's not exactly 30 miles per hour, so you would be wrong. This is the exact answer. Okay, so tough problem. A lot of people mess that one up. All right, number 5 and 6, classic rate times time equals distance problems. Go ahead and set these ones up on your own and see if you can figure them out. All right, so for number 5, it says one car is traveling at an average speed of 50 miles per hour. Another car is going at a rate of 55 miles per hour. If both cars make a 550-mile trip, how much longer will the slower car take? So in this problem, it ends up kind of being a 2 for 1. You end up doing 2 rate times time equals distance situations. So for car number 1, we'll just do a little table here. For car number 1, don't mind my terrible table here. For car 1, it says it's going 50 miles per hour. And for car 2, it's going 55 miles per hour. Both cars are making a 550-mile trip. and we are trying to figure out how much longer will the slower car take. So with both of these, we are looking for the time. Now when you do your division here, because you end up dividing 550 by 50, that would get you 11 for this one car. And when you do 550 divided by 55, you get 10 hours. So this car is going slower. It's taking longer than this car, and the amount of time that it's behind would be 1 hour. It is a 1 hour difference between this car and this car. So your answer would be Bravo. Okay? All right, for number 6. This is like the kind of problem that everybody has nightmares about in school. The trains heading in different directions. This is kind of like that classic problem. Okay, so train A traveled 180 miles in 3 hours. Train B, heading in the opposite direction, traveled 225 miles in 5 hours. How fast were the two trains separating? Okay, this is also going to be a 2-for-1 situation, just like this one here. We are going to have to figure out what rate each train is traveling at per hour. And then what we're going to do is we are going to add those numbers together, and I'll show you why. So first off, let's do our table again. So train A, number A, and train B. Let's see if I can make my table look a little nicer. So rate times time equals distance. Okay, we don't know the rate here. That is what we are trying to figure out for both of these problems. The time we do know. For train A, it says it travels 180 miles in 3 hours. So in 3 hours, it's going 180 miles. For train B, it says it's traveling 225 miles in 5 hours. So the first thing that I'm going to figure out is figure out the rate that each train is traveling. And for that, you would end up doing 180 divided by 3, which is 60. And then 225 divided by 5, which is 45. Okay, now here's the tricky part. The question is, how fast were the two trains separating? Remember, they're traveling in opposite directions. So if I were to draw a picture, let's say this is the train station, and train A is going this way, and train B is going this way. Okay, so after 1 hour, train A has gone 60 miles. So this distance right here represents 60 miles for train A. Train B has traveled 45 miles in 1 hour. 45 miles, 60 miles. So train B in 1 hour has traveled 45 miles. So that means after 1 hour, these two trains are 45 miles apart here and 60 miles apart here. So they are in total apart 105 miles per hour. So the question is, how fast are the two trains separating? This train's traveling at 60 miles per hour. This train's traveling at 45 miles an hour. That means collectively after 1 hour, they are traveling they're separating at 105 miles per hour apart. Tricky problem. If you struggle with that one, don't worry, you're in good company. A lot of students tend to get confused with that one. All right, I hope that was helpful. Remember, with rate times time equals distance, I mean, it's a pretty easy to catch these kinds of problems. Some person or some item is traveling at a certain rate for a certain amount of time and a certain amount of distance. They're not going to give you one of those things. So just write out your formula and plug in the numbers that you know. All right, have a great day, and I'll see you in the next video.